Okay. Easy way to describe this one. When we look at this, this is R3, R4, okay? All the rest are up here. So, where are we? Number 13, is it?
13
13.
Hello.
Hello.
Okay,
Hello.
he's here.
Okay. R3 here. Resistor 3.
Yeah.
What is the resistance value?
R3.
Yeah. The resistance value. How many ohms?
20
20 ohm.
Good job. And then R4. What's the resistance value?
20 ohm.
Good job. Easy way to remember this. If they're the same number, okay, if they're the same, so 20 ohms, 20 ohms, it's half. Okay, so it's half of, if you've got parallel and two are the same, like this, 20 ohms and 20 ohms, it's half of one resistor. Only if they're the same. Same, half. Okay. How am I?
Okay, understood.
Yeah, okay, got it.
Okay, good. I'll go back over to this again. This is a pain, this really is.
หน้าห้องฝากที่เหลือด้วยเดี๋ยวไปทำแผลแป๊บ
So the equivalent resistance is going to be 5 ohms. To calculate the total resistance for two resistors in a parallel circuit, it's 1 over R1 plus 1 over R2 raised to the minus 1. So this is going to be 1 over 10 plus 1 over 10 raised to the negative 1. Now 1 plus 1 is 2, so this becomes 2 over 10. And when you raise a fraction to the negative 1 power, you basically flip the fraction. And so this becomes half of 10, or 10 divided by 2, which is 5.
Okay, so what he's said here, what he's done is he's calculated in parallel the total resistance. What you would do normally is you would go, so 1 divided by 10, which would be R1, plus 1 divided by 10, which is R2, close. So the negative power of 1, it gives us 5, okay? But what they're saying here is you can use fractions also. So when it's the negative of 1, you just swap the fraction around. So it's 2 out of 10, 2 divided by 10. Negative 1, you put 10 divided by 2 equals 5. Kajamai?
Ew.
Okay. Everyone can see YouTube, yeah?
Yes.
Okay, good.
Now what if we have 3 resistors in parallel?
Okay.
Let's say this is a 4 ohm resistor, a 6 ohm resistor, and an 8 ohm resistor.
Okay. Let's see if we can do this equation together. Yeah? Can you all see my calculator?
Oh, where's your calculator?
Oh, this is a nightmare. Okay, 1 minute. Now?
No.
Okay, I'm not sure I can do it. Oh, this is really annoying. Tom. 1 minute. Okay, let's try it this way. So now we can see YouTube, yeah?
Yes, I can see
Okay. And you can see my calculator.
you. Yes.
Oh, good, finally. Right, okay. So let's say we have R1 on the left, in the middle, R2, on the right, R3. All of these are in series, yeah? Resistor 1, resistor 2, and resistor 3 are in series, yes or no?
What?
Okay. Resistor 1, resistor 2, resistor 3.
Yeah.
These are all in series, correct?
Nope.
No.
Good job. So they're
It's
all
in
in parallel.
Primary.
Nice. Good job. Primary? Okay, yeah. They're all in parallel. So the way we do this is a little bit different, I think, to what teacher Ott was teaching you. Okay. So the way I do it would be open bracket. 1 divided by resistor 1, which is 1 divided by 4, plus 1 divided by resistor 2, which is 1 divided by 6, plus 1 divided by resistor 3, which is 1 divided by
8.
8. Okay, good. Close bracket to the negative power of 1. Okay, this will give us our total resistance in this parallel circuit, which would be 12 over 13, 1.846. You might not hear the sound, but I'm going to speak rather than the sound if it doesn't work. Can you hear the sound?
No.
Okay, I'm going to speak. I'm not going to keep turning it over. So what's the equivalent resistance of this circuit? We have just done this.
Relation.
So R1, R2, R3. Here's our formula. R equivalent is 1. Okay, like I told you, to find this, the resistance equivalent, 1 divided by R1, 1 divided by 4, plus 1 divided by R2. So that's 1 divided by 6, plus 1 divided by R3, which is 1 divided by 8, to the negative of 1. Like this, like this, like this. So exactly how you see it here, you bracket like this, bracket, close bracket to the negative of 1, and you will get this reading. And let's see what happens. So 1.846 ohms. Let's make sure we're right. 1.846. Okay. Now I want to come back over. Stop presentation. Back to multi-sim. So 1 minute. Oh. And, multi-sim. Sure. Okay, you can see this here. Can you see multi-sim?
No.
No. This is a nightmare. I really hate this. Stop presenting. Entire screen. There's got to be an easy way of doing this, surely. Okay, can you see this now?
yes
Okay, good. Let's get rid of this. Let's get rid of this. This, rid of this. Okay. So we're just going to stick to something like this for now. Change this to, let's say, 25. Now they're not the same value. You can't do half. Remember, same value. If it was 20 and 20, or 10 ohms and 10 ohms in parallel, you could half it. So 10 ohms and 10 ohms would be 5. 20 and 20 would be 10 ohms resistance. Now they're not the same. We have to do a different calculation that we just learnt. So we go like this. Then we go like this. Okay. So number, where are we? Number 17.
yeah.
Okay. So we
Um,
have,
oh his microphone not working
oh, okay. 18.
18
Microphone not working.
too bad
19.
9
Okay, buddy. So we have 2 resistors in our parallel circuit. Resistor 3. What is the resistance in resistor 3?
ใน R3 มีค่าเท่าไหร่
34.
Okay, 34, yeah? So 34 ohms in R3. In our resistor 4 here.
25 ohm.
Nice, good job. Okay. So now to do this, I'll help you with this one, and then we'll change it. Okay. Remember our equation. Now, what we do to find out the total, we'll open bracket. Yeah. 1 divided by 34 plus 1 divided by 25. Close bracket to the negative of 1. 850 divided by 59, let's find out. 14.406. Let's see if this is right. 14.407, which is good because it's rounded it up. See, 14.4067. So we've gone up a number here to 14.407, which is fine. Okay, let's change the numbers. And then 19, are you there?
ได้อยู่บ่
19.
19ฮัลโหลยังอยู่ไหม
Are you there?
He is here.
Okay, good. Tell me how to find the resistance equivalent in this parallel circuit.
Teacher ถามว่าอะไรอ่ะ
It'd be easier if you can see this, you know. Okay. Let's try and do one where you can see it. To find the resistance total, yeah, we would do 1 divided by 12 plus 1 divided by 17, yeah, to the negative of 1. Always negative of 1 at the end when you're calculating these parallel circuits. Always remember negative 1. So what we'll do is get it up. So we'll do 1 here divided by 12. 1 divided by 12 plus 1 divided by 17. Okay, close bracket to the negative of 1. And we equals, find out, 7.034. Yeah? So our total resistance in this parallel circuit is 7.034. There we go. 7.034. Kaljamai?
Okay, now I understand.
You understand now, yeah? A little bit easier. Let's do one more. 13. 35. Let's. So remembering how we do this. What's the first thing anybody can answer now? The first thing, the first sum we have to do.
Divide.
Okay, what's the first
Oh.
thing we have to do? Number 1.
As we divide R4.
No. Remember, we do 1 divided by.
Ah,
divided by 13.
Good. Yeah. And then we plus that by
1
1.
divided 35.
35. Yeah.
I got it.
And then that, then to the negative of 1. Yeah. So if we write this in our calculator as open bracket 1 divided by 13 plus 1 divided by 35 close bracket to the negative of 1, we have 9.479. And hopefully we should get 9.479 ohms. Always remember, all we're doing is 1 divided by the resistor. Add 1 divided by the resistor. So we have 1 divided by R1 plus 1 divided by R2 plus on. Kajamai?
Got it.
Sure. Let's okay, one more, and I'm going to ask somebody because in English this is probably so confusing for you. Let's say number, where are we? 21?
21.
I'm here, teacher.
Okay, buddy. So remembering how we calculate our resistance in this circuit, how do we do it? Can you tell me?
เราจะคำนวณบวกลบคูณหารอีกค่าในวงจรนี้ยังไง
ทำเหมือนอันแรกอะนะ
ใช่แล้ว
1 divide 11 plus 1 divide 56
Oh, sorry. And then-
minus 1
Good. Always remember -1 well done for everything at the end. So then if we get our calculator up, and then we go open bracket 1 divided by 11 plus 1 divided by 56, close bracket to the negative of 1. It will give us 9.194. Let's see what happens. 9.194 is our total resistance. Okay? Right, let's move on. Watch the rest of the video. So here's doing another example now. So what he's done here is he's put parallel series circuit this time. Yeah. So these two resistors here, they're in series, yes? Are they in series?
Parallel.
Okay, good. Okay, so these two 20 ohm resistors, are they in series or are they in parallel? Number, let's go back to, I don't know, number 24. Yusuf C?
We got only 23.
Okay, 23, Yusuf Sam?
เอาละ13อยู่ไหมเนี่ยHis class
Microphone's not working. Number 1?
Okay. This microphone not working too.
Okay, number 2?
Control.
Okay, buddy. So these here, 20 ohm resistor, this 20 ohm resistor, are they in series or parallel to each other?
เปล่าเขาถามว่าอะไรนะ
อันนึงนะTeacher, can you say that again?
Yeah, sure. So we have 20 ohm resistor here and the 20 ohm resistor here. These two, are they in parallel or are they in series with each other?
อ๋ออันเนี้ยมันอยู่ในวงจรขนานหรืออนุกรมค่าความต้านทานสองอันเนี้ย
เขาต่อกันแบบไหนเพื่อนแปลได้ถูกต้องนะครับ
ขนานนะครับ
ตอบอังกฤษเพื่อน
พูดเป็นภาษาอังกฤษได้ไหม
parallel
Parallel, nice, good job, well done. Thank you. And this 15 ohm resistor will be in series. Okay, once we deal with this, which it is in series now. But watch what we do to figure this out. So first, what we do is we find the resistance between the parallels. So we can turn it into one resistor here. So we know if the two resistors in parallel equal the same value, half, good. So half of
20 is 10.
good job. That then turns us down to this. So now we have this. So now on the right hand side here, we've turned these two into one. Now our circuit is in series. And what do we do to find RT in a series circuit?
Put it together.
How?
Put it together. Or
Yeah,
plus it.
so just add it together, yeah?
Yeah.
So, I mean, don't even need the calculator for this. So 10 plus 15 is
25.
25. Okay, so let's do a couple on multisim like this. Okay. Let's say we go like this. Like this. We go like this, and then plus. Sorry, 1 minute. Just going around to it. Okay, it's not very pretty. I'll move this up one. So basically, we've got a circuit that looks like this now. Okay, let's see if we can remember how we work these out. So we'll keep it as 11, 11, and 56. Let's move a little bit closer like this. Okay. So remembering how we work this out, we work our parallel out first. Okay, so then we can put it into series. So what do we do to work our parallel out? Parallel resistance here. Anybody?
1 divide 11.
Good job. It's right here above.
Plus 1 divide 56.
Good job. And then
And minus 1.
minus power, yeah? So then if we get this, we do this, blah, blah, blah. 1 minute. 1 divided by 11 plus 1 divided by 56. That's right. Yeah. It's a negative of 1. We then have 9.194. So what we can do is delete this. Delete this. We have a value here. Then we have a value now, because we've turned the two parallels, calculated them to 1, which now gives us a series circuit. Okay? Let me just make sure that we have this right. 9.194. Yeah, good. Now we know in our series circuit, we just add these together. Simple. So we would do 11 plus 1.914 equals 12.914. Let's hope we're right. 12.914 is our total resistance. See how we just made one big equation, something that looked very complicated here. We turned it into something very easy by doing these two first in parallel, and then it leaves us in series. Kajai?
Yeah.
Yeah? Okay, well, we'll quickly do one more. really quickly. Let's see if I can stop this. Undo. I don't know what's going on there. Okay. Do one really quickly, and then we've got to bust on with something else. Okay. So now we need, let's turn this to, let's say 100, let's do 120. Let's turn it up a little bit. We'll turn this to, let's say 390. And then this to 6, I don't know, let's do 311. Okay, so what is the first thing we do to make it easy? What's the first thing we do?
1 minus
So we find out the total of the parallels first, yeah?
1 divided. Yeah.
Oh.
Get the parallel
Yeah.
first. Get it.
Okay. So what's our equation? How do we find?
Get the 1 divided.
So we'd go open bracket, yeah,
Open the blanket. Get the 1 divided. 120.
yeah.
Divided. The
Yeah.
plus 1 divided 390.
And
Plus
then,
get and minus 1.
yeah.
Boom.
Then if we do this calculation here, 1 divided by 120 plus 1 divided by 390, close bracket, and then this. It gives us 91.764. So what we can do is just delete this, change this to 91.764. Pass this along here a little bit. Then we are in series. When we're in series, what's the equation we do? How do we add the total resistance? So it would be 311
Plus 91.6. Oh no, 764.
764, yeah. Then if we find out this, we'll go 311 plus 91.764, 402.764. Let's see whether we got this right. 402.764. So we're just making it really easy for ourselves. Right, we've got to speed up a little bit now. So nice and easy, yeah? Now it's going to get a little bit more difficult. So 40 ohm resistor here, 40 ohm resistor, 20 ohm resistor. We're going 5 for R1, 15 for R2, and a 30 ohm resistor at the bottom here. Okay, so these two are in parallel. Let me turn this off. These two are in parallel, and they have the same resistance. So what do you do?
Half.
Half. Half of 400 is
20.
20?
Yeah.
It's a 40.
Oh, sorry, yes, 40. Okay,
40.
yeah. So I'm sorry. It's not a very good ohm sign, is it?
What does it look
Okay.
like?
So yeah, half of 40 is
20.
good job. Nice.
And how 20 is 10.
So now we know we have a 20 ohm resistor here, so we can delete this now. Gone. Now we have a 20 ohm here, 20 ohm here. What do we do when it's the same value?
Half again.
Half. Good. Half of 20 is
10.
good. Now we can delete all of this. Just add a 10 ohm resistor. Yeah, and this is the equation we could do. Yeah, if we didn't know that you could half it, the equation you would do is 1 divided by 40 plus 1 divided by 40 plus 1 divided by 20 to the negative of 1. And the answer would be 10. So it all adds up to 10. And he's just made this really easy. He got rid of the parallels. Now they're all in series, so we add them together. Plus 10 plus 30. So what is the equivalent resistance here? Who can tell me? Or in the
35.
how much? So 5, add 15, add 10, add 30.
85.
Ah?
What? It's just the 30 down.
Yeah, 30, yeah. So 30, add 10, add 15, add 5.
60.
60, yeah, we got there in the end. Nice.
Hey, up here and down there, I didn't see,
Yeah, so I've done the same thing. Okay, nice and easy. Really easy to break that down. Different example now. So we've got 10 ohm, 20 ohm, 30 ohm. So these two are in series because there's only one path for current to flow, and that's this way, and this way. So what we do, if these are in series, we just add 10 plus 20, which is 30 ohms, yeah? And that'll leave us in parallel, like this, with the other 30 ohms. Then obviously so once these two are done, and they're added together, the series, these two are then in parallel. Okay, and then nice and easy, they're both the same equivalent, 30 and 30. So what's the total resistance? 15. Nice. And a good way of, obviously, instead of just doing that, let's prove that we're right. So 1, open bracket, 1 divided by 30 plus 1 divided by 30, close bracket, so negative of 1, 15. There we go. So half of 30 is 15 because they're the same equivalent. Things become a little bit more complicated now. So we're going to have 1, 2, 3, 4, 5, 6 resistors. 10 ohms, 20 ohm, 30 ohm, 60 ohms, 10 ohms, 20 ohms. Okay. So now we need to calculate the equivalent resistance. So we're going to go in series first. So we know 10, 20 ohm, 30 ohm. These resistors are in series. Okay. So what do we do to find out the total resistance of these? These are in series. So what do we do?
You put it together.
Yeah, so we just plus them together. Okay. So 30 plus 20 plus 10, ally?
60.
60. Okay. This will then put us parallel with this resistor. Now, we know these two parallel is going, the equivalent will be half that of one resistor. So half of 60 is
30.
good. So now we know we can do this. So half of 60, which is 30. And now we are in series, and we just add them all together. 10 plus 30 plus 20 is
60. 60.
60 ohm. Yeah. Nice. Nice and easy, yeah?
Yeah.
So one more example. This one's going to be a little bit more difficult, a bit more confusing. So here we have 1, 2, 3, 4, 5, 6, 7, 10 resistors. Is that right? 1, 2, 3, 4, 5, 6, 7, 10 resistors. So here we have 30 ohm, 50 ohm, 40 ohm, 5 ohms, 20 ohms, 30 ohms, 20 ohm.
Excuse me, can I go to toilet?
Yeah, of course, yeah.
Okay, thank you.
15 ohm, 5 ohm. So now he wants us to calculate the equivalent. So he's going to redraw the circuit because this is confusing. So now he's using positions, okay? Now it's got a little bit more complicated. He's going to use point A, point B, point D, point C, point E. So these two here are in series, and then these two are in parallel with this. Okay, so what he will do now is draw it like this. So what he's done is he's just put this parallel with these two. So the 15 ohm resistor at the top and the 5 ohm resistor is now parallel with this 20 ohm resistor. So point E and point D. See here? So now we know it's going to be same here. So the 30 ohm resistor and the 20 ohm resistor. Yep, so we've got point C, which is between here, and we got a 20 ohm resistor. Like this. A 40 ohm resistor here between B and A, and then a 5 ohm resistor between A and D. $50 ohm here, and a 30 ohm resistor here. So now we can get rid of this. And then this now makes more sense, yes? Because we can do our parallels and then work our series. So these two are series, so it'd be 20 ohms, 5 plus 15. Then these two are in parallel. 220s, they are equivalent, so we half that, which will be 10 ohms over here. Ten ohms here. Okay. Now this, we need to decide what we're going to do at this point. These two guys here, they are not in series. They're in parallel because there's two different paths the current can take. Yeah. If it's not one path, it's parallel. And this can take two. Look, it can come down here or it can come down here. So these two are in parallel. Now these two, oh no, I'm sorry. Okay. Okay. Now here, between 10, this resistor and this resistor, we are in series because there's only one path the current can take. Let's try and keep up with this. Like I say, so the current can only flow one way, but these two are in series. So what we would do is we will add these two together. 20 plus 10 is 30. This will leave us in parallel with this. So now we can put this in parallel like this. Okay, so these two are in series, nice and easy. So now we've added these together. We're going to have a 30 ohm resistor in parallel with this 30 ohm resistor. And we know that equivalents, when they're the same, it's half of one resistor. So it'll be 15. So now we're going to put this resistor here at a rating of 15 ohms. These are all in series. As you can see, you can only go one way. The current can only go one way. So we add all of these together. 20, add 15, add 5. That's 40, yeah? So we've got 40 in parallel with this 40 ohm resistor. And these two are equivalents again. So 2 equivalents will be half of one resistor, which is 20 ohms. Okay. And now all of these are in series. So all we do is add these together. 30 plus 20 plus 50. 100 ohms altogether. Nice and easy that. เข้าใจไหม Everyone asleep? เข้าใจไหม I'm sorry.
What's going on? Okay, I'm back.
What's going on? Yeah. I bet. I'm so sorry. It was really confusing. Maybe when you have some free time, watch the video again. But with him speaking, it's hard for me to keep up with him because I don't know what he's doing until afterwards. Other than that, any questions?
No.
You sure? There must be some questions. Oh, okay. Okay, teacher.
โอเคอ่ะจบแล้วนะ ก็ถ้านักเรียนไม่เข้าใจไหนเดี๋ยวนักเรียนมาดูคลิปย้อนหลังได้นะครับ แล้วก็วันนี้เช็คชื่อแล้วขาดคนเดียวนะคือเลขที่4นะครับเลขที่4ไม่มาคนเดียวคนอื่นมาครบนะครับเสร็จแล้วเดี๋ยวเราจะมีแบบฝึกหัดให้นักเรียนทำนะครับในแบบฝึกหัดนี่ครูใส่ไว้ให้แล้วนะเดี๋ยวแป๊บนึงแบบฝึกหัดนะครับในสัปดาห์ที่8เนาะวิก08นะครับก็จะมีงานมอบหมาย3ข้อด้วยกันนะครับคือในแต่ละข้อเนี่ยก็จะเป็นเหมือนที่เราอธิบายไปนะครับให้นักเรียนแสดงวิธีการยุบตัวด้านทานนะครับว่าทำยังไงก็ให้เขียนใส่สมุดหรือกระดาษก็ได้แล้วถ่ายรูปส่งว่าวิธีการทำนักเรียนทำอย่างไรโอเคนะครับจะเป็นลักษณะแบบนั้นมี3ข้อด้วยกันเมื่อกี้ก็เป็นข้อ1อันนี้ก็จะเป็นข้อ2นะครับนักเรียนต้องเปิดเข้าไปดูก็อันนี้ก็ให้หาค่ากระแส I3 ก็คือกระแสที่ไหลผ่าน R3 ตัวนี้ว่ามีค่าเท่าไหร่นะครับเพราะฉะนั้นมันไม่มีคำตอบนะครูจะดูวิธีการเป็นหลักว่าวิธีการถูกไหมถ้าวิธีการถูกคำตอบก็น่าจะถูกนะครับอันนี้ ข้อนี้ที่ครูพลาดไปก็คือไม่ยากหรอกเพราะว่ามันมีตัวอย่างอยู่ใน example อยู่แล้วแต่อันนั้นมันเป็นขั้นตอนที่ไม่มีค่าความต้านทานแต่อันนี้ใส่ค่าความต้านทานเข้าไปนักเรียนแค่ไปดูตามตัวอย่างนั้นแล้วก็ทำไมครับแทนค่าลงไปเพื่อหาว่า RT หรือ R equivalent เนี่ยตัวจุด AC เนี่ยมันมีค่าเท่าไหร่นะครับทำนักเรียนต้องวาดรูปด้วยนะครับวาดรูปนะวาดรูปเพราะฉะนั้นก็จะเป็นงานมอบหมายให้นักเรียนทำนะครับทีนี้งานที่มอบหมายเนี่ยก็ให้เวลาถึงนู่นน่ะสัปดาห์หน้าเราสอบนะครับเป็นตารางสอบในตารางนักเรียนเข้ามาเรียนปกติครูจะทำข้อสอบไว้นะครับแล้วก็ให้นักเรียนทำเข้าใจไหมครับคือตารางสอบจะตรงกับตารางเรียนปกติเลยเพราะฉะนั้นวิชาไหนจะสอบหรือไม่สอบก็แล้วแต่อาจารย์เขาแต่วิชาครูจะมีข้อสอบให้นักเรียนทำเพราะฉะนั้นก็เตรียมความพร้อมให้พร้อมนะครับวันนี้มันอาจจะซับซ้อนนะครับแต่ต้องใช้เวลาฝึกทำด้วยครูหวังว่านักเรียนคงจะเข้าใจนะแล้วก็ไปทบทวนนะครับความรู้เดิมๆนะว่ามีอะไรบ้างสงสัยถามได้เลยนะอาจารย์เขาพร้อมจะตอบคำถามอยู่แล้วไม่ต้องเขินนะครับถ้าสงสัยแล้วไม่รู้จะถามไงปรึกษาครูได้ปรึกษาเพื่อนก็ได้เนี่ยนะครับเจนิพัฒน์กับศักดิ์นรินทร์เขาพร้อมให้คำช่วยเหลืออยู่แล้วทีนี้มอบหมายงานเสร็จแล้วทีนี้เดี๋ยวตอนไม่รู้ว่านักเรียนจะต้องใช้เวลาทำนานไหมน่าจะนานไหมครับเจนิพัฒน์แบบฝึกหัด3 ข้อนี้
3 ข้อนี่แล้วปริ้นเอาแล้วก็เขียนนะ
วาดเอาก็ได้ในกระดาษไม่ต้องปริ้นหรอกเปลือง
แต่ผมเอาภาพไปแปะในเวิร์ด
ในเวิร์ด
ในเวิร์ดแล้วก็ทำเป็นโจทย์ออกมานี่ได้เหมือนกันหรือเปล่า
ครูไม่ได้หวังว่าต้องทำซับซ้อนขนาดนั้นเราเขียนวาดใส่กระดาษก็ได้เพราะยังไงมันก็ต้องใช้มือวาดอยู่แล้วใช่ไหมครับก็แล้วแต่นักเรียนนะแสดงเป็นขั้นตอนเหมือนตัวอย่างที่ครูทำให้ดูว่ายุคขั้น1ขั้น2ขั้น3ซึ่งในเอกสารครูได้ส่งไว้ในคลาสรูมให้แล้วตัวอย่างเนี่ยนะครับตัวอย่างนี่อยู่ใน PowerPoint นะครับจัดอยู่ในนี้นะ cp problem doc นะก็มีขั้นตอนให้โอเคไหมครับทำใส่ไว้ให้แล้วนะส่งให้นักเรียนแล้วเป็นไฟล์ Word ด้วยนะครับอันนี้ครูทำให้ดูเป็นตัวอย่างนะก็ลองดูแล้วกันนะครับใครสะดวกเขียนก็เขียนนะครับเขียนใส่สมุดหรือกระดาษก็ได้กระดาษก็ว่าใส่สมุดดีสุดนักเรียนจะได้เก็บไว้ดูโอเคนะครับเรียบร้อยมีอะไรจะถามครูไหมไม่มีเนาะ